Broadcasting live. It's America's longest running talk show on computers. It's Computer America, bringing you the biggest names in technology with guest interviews, new products, and your emails. Listen live at computeramerica.com on any device around the world. Email the show at live@computeramerica.com or find us on social media. Be sure to check out our website for contests, giveaways, show notes, live video stream, podcasts, and more. You're listening to Computer America.
Hello and welcome everyone into the Computer America Show. We are the nation's longest running. Everyone, welcome into the Computer America Show. We are the nation's longest running, nationally syndicated radio talk show on computers and technology. And everyone, welcome onto the program. I hope that you're doing well and you are ready for today's show, because today on the show we have a very fun one for you, where we have the one, the only Mr. Ralph Bond. He is our science and tech trends correspondent for us here at Computer America. And what that means is he comes in with a number of stories that are, science and tech trends. There are things that are have been happening, research, early stories, but on top of that, there are stories that you might not have heard of. That's, I think, one of the most important parts that we don't emphasize all the time, which is, these get pushed down so often by other stories, bigger stories. It's not that these stories aren't important. It's just, hey, there's so much to pay attention to over the course of a week. And Ralph joins us every single Friday to talk about some very fun stories. So with that being said, computeramerica.com. That's where you'll find everything from past shows, future shows, show notes, articles. And of course, the show notes are super important because Ralph does an amazing job of putting them together, and you can find them at our website with links, sources, videos, demonstrations, anything that we do here on the podcast. If you're listening to us, thank you so much. But if you are watching us, you're going to get a little bit more of an experience. So we encourage you to check out the video as well. So with that being said, let's go ahead and bring Ralph on and, hey, just have a very nice, enjoyable show. So with that being said, Ralph, welcome back onto Computer America. How you been?
I'm doing great. It's always great to come back and always great to do every Friday what you and I do. And friends, if you're new to the show, what Ben and I do each Friday is highlight 4 recent articles that show us key trends and developments in all kinds of things. Of course, artificial intelligence, robotics, medical technology, sustainable energy technology, transportation advances, agricultural technology, space research, physics. Wow, you name it. But most important of all, especially given the kind of news week we've had this week, oh my goodness. But the most important thing of all is we're going to give you an oasis of positive, uplifting news thanks to the world of science and technology.
Absolutely. And I think we're just going to jump right into story number 1. And for anyone out there who has ever sorted their recyclables, and, I've seen, plastics in particular, what is recyclable, what isn't. I think there's like 16 different grades of plastic, and you have to kind of sort them out from a grade 9 to a grade 3 to a grade 16. Ralph, some of these plastics, you have to sort them out because not all plastics are created equal. And, well, story number 1 finds a way to, make that maybe some of the more, less digestible plastics, a little bit easier to deal with. So story number 1.
You got it. Story number 1, first of all, comes from an outfit called No Ridge. That's KNOWRIDGE.com. And this is the first time I've pulled a story from these guys, and it's really interesting. And by the way, what they are, it's called No Ridge Science Report. It's an independent online magazine that publishes science, health, mind, earth, and space news. And it was founded in Sydney, Australia in 2016. So it's been around for a few years. Hey, folks, check it out. It's really, really cool. And this, reminds me, come out and get the show notes at computeramerica.com, because we'll have links, images, and so forth. Especially if you're listening to us as a podcast, you really need to get these resources to fully understand what we're talking about. So let's get into this story. Researchers at the Korea Institute of Energy Research have developed South Korea's first continuous gasification system to convert hard to recycle thermoset plastics into synthetic gas and as a feedstock for hydrogen fuel production. So there's a lot to unpack bind here for a second. Let me take a quick sip of coffee because I got a little
you're
tickle
good.
in the throat
Absolutely.
here.
Yeah, no. Take a little sip of coffee, and ladies and gentlemen, just real quick, just wanted to remind everyone that at our website you can also we've done a little refresh. Just like a week or two ago. Everyone out there should go check it out. And then of course at the top we have a whole segment dedicated to Ralph and all of his shows and all of his segments. So if you want just Ralph news, and Ralph, I actually do like separating your segments out in particular a little bit because what we do is so future looking that even shows from a couple months ago are still extremely relevant. So yeah, people should go check that out. So anyways, you should be good now. Let's go.
I think I've got the tickle throat problem conquered.
Good.
So what we were saying is that this outfit, Korea Institute of Energy Research, they've developed the first continuous gasification system to convert hard to recycle thermoset plastics into synthetic gas, which in turn becomes a feedstock to generate hydrogen fuel. And so, Ben, you and I have seen so many stories over the past couple of years about all these different ways people are trying to figure out how to create green hydrogen. So green hydrogen as opposed to hydrogen generated from natural gas and so on and so forth. And before we go on, as the show notes indicate, we need to kind of define, wait a minute, what is thermoset plastics and what do we mean by a feedstock? So first, thermoset plastics, commonly used in automobiles and electronics, cannot be remelted or reshaped, making them difficult, to say the least, to recycle. And a little quick side note, and by the way, in the show notes, I inject a lot of extra tutorials and information to explain and define things. And this is a good example. We're not going to go through every single part of this, but I will give you the highlights here. So thermoset plastics are polymers that harden irreversibly when cured, making them heat resistant and durable. Well, that's great, but horrible when it comes to recycling. And by the way, here are some common examples. I'll give you just two out of the stack that's in the show notes: epoxy resins and polyurethane. I've heard of those. And they're in that category of thermoset plastics. And just say
that, I'm sorry, I just wanted to say that, when it comes to packaging, you always have to measure what is shelf stable, what's sustainable, and what can make it through shipping and handling and all that good stuff.
Right.
But then, Ralph, if it's very durable, that means it's very hard to recycle. That's why everyone, you love the idea of paper straws, but not everyone loves using paper straws. There's always the trade-off.
You're right, Ben. And in the world of automobile production, thermoset plastics play a huge role for obviously the durability reasons and so forth that make them attractive. But on the flip side of it, recycling is the terrible problem. Mm-hmm. And then to define what is a feedstock for hydrogen? So a feedstock for hydrogen fuel refers to a raw material used to produce hydrogen through various chemical or physical processes. And common feedstocks include, and here again, we've injected into the show notes, natural gas, water, biomass, and in this case, now, hard to recycle plastic waste. That's the big news here. So back to the news story. The Korea Institute of Energy Research team is using thermoset plastics as a feedstock, meaning they are broken down at high temperatures to release hydrogen, which can then be purified and used as a fuel. Very cool. But here's how they do it. The new method uses high-temperature gasification powered by oxy-fuel combustion, maintaining reaction temperatures of up to 1,300 degrees Celsius. That, by the way, is 2,372 degrees Fahrenheit. Wow! To process 1 ton of mixed thermoset plastic per day in their experimental plant. And in the show notes, folks, if you're going oxy-fuel combustion, what the heck is that? Come out to the show notes, check it out, because I've injected here a whole tutorial on what that is and the key benefits of it and so forth. It's very, very geeky, but you can check it out if you want to. So it's pretty interesting. So that high temperature thing, Ben, is a stunning accomplishment. And right now, they can process 1 ton of thermoset plastic for this purpose. Pretty cool.
Yeah, it's really, and part of me was like, well, are they really making more energy than they're producing, or I'm sorry, are they producing more energy than they're consuming, that kind of thing? But it's not even so much as like, it's a trade-off. It's like, well, you can generate this anyways, and you are also recycling previously non-recyclable things, and that's a super important aspect of this. So
yeah,
nice.
you raise a good point, because in the world of recycling, there's sort of a if you think of it like a input output kind of algorithm, if you want. How much energy do you need to do what you want to do in terms of recycling something? And so that's a good point. But they feel like they've come up with an equation that is a net positive.
Mm-hmm.
That's the thing that's key. And I'm glad you raised that point, because that's something a lot of times we just sort of take for granted. So the Korea Institute of Energy Research pilot plant, which we have a picture of it in the show notes, demonstration showed that every kilogram of mixed thermoset plastic waste, every kilogram can yield about 130 grams of hydrogen, offering a viable route to produce clean fuel from previously unrecyclable plastics. Now, the team plans to scale up to a facility capable, ultimately, of handling 2 tons of thermoset plastic per day, advancing toward full commercialization. So they have a roadmap in mind. It's not here now, but they're on their way. And this innovation promises to reduce plastic pollution while supporting sustainable hydrogen economies. Pretty cool stuff.
It makes so much sense, because and this is speaking of trend, turning waste into something useful. Ralph, you can imagine that before this process and previously unrecyclable things, like, it has to go somewhere. Odds are it's a landfill, probably in another country. Countries love to ship just tons of waste and plastic that they can't do anything with off to other countries, Ralph. I can imagine the fuel source for this, well, not the pure oxygen, but the fuel source for this, the plastic, is super cheap, because no one can do anything with it anyways, and it's already garbage. So yeah, turning literal garbage that, hey, maybe even someone will pay them to take it, and then turn it into fuel as a byproduct. I mean, it's a win-win, which is another common theme among these stories. So
yes, yeah, absolutely.
Very good article from No Ridge, and very good article from Korea. So there you go. Great story number 1. Story number 2, we're going to go ahead and scroll down, and let's talk about, well, Mars. And Mars has always kind of held this idea that it's our closest other planet. We always want to be able to go to it, and it's an aspiration that we are actively working on. When we get there, 2035, 2028, who knows? Someone out there smarter than myself is getting there. But what if we can make it somewhere that we actually want to go? Like, what if it's actually, kind of nice there? So let's talk about story number 2.
Yes. This comes from ZME Science. The headline is Terraforming Mars might actually work, and scientists now have a plan to try it. So this is irresistible. I had to check this out, and it's a fun story. And you're going to find out it's not near term, folks. We'll get into that in a moment here. So in a new paper, a group of planetary scientists, biologists, and engineers from Harvard, Pioneer Research Labs, University of Chicago, and many other institutions. So this is a paper that involves a lot of experts. In this paper, they make a case for treating Mars as the ultimate ecological experiment. The study outlines a 3-step phased plan for making Mars habitable over centuries. So, folks, this is probably the most far out, long-term thing, Ben, you and I have ever discussed. Talk about a trend that's just twinkle in the eye, early research. We're talking about something that's going to take centuries to achieve, but it's still very interesting.
But the payoff is a whole second planet. That's good payoff.
Yeah, it could be. And you're going to find out, too, that there's a near-term benefit out of all of this research. So the first phase in the paper involves increasing the surface temperature of Mars using methods like solar sails, engineered aerosols, that's interesting, and silica aerogels to trigger greenhouse gas feedback loops. Now, that's very geeky stuff. You can find out more about that in the research paper. We have a link to that in the show notes. You can get geeky on that if you want. The next step, step 2, the scientists propose introducing genetically engineered microbes capable of surviving on the harsh conditions of Mars. And these so-called extremophiles could begin generating organic material and altering the planet's chemistry, again, over a very long period of time. Pretty amazing.
Yeah.
And
it's just like in our garden. And, whenever we want to grow moss on a boulder, you mix some yogurt and some moss and you spread it over the boulder. It's the same thing, except it's just a whole planet. How hard can it be?
Yeah, that's right. And the third level, And then over time, believe me, over time, efforts would focus on creating an oxygen-rich environment that could support human life without spacesuits or pressure suits. I mean, ultimately making an Earth-like environment where instead of having to just huddle inside of extremely protected structures and then having to wear extremely bulky suits just to even go outside on the surface of Mars, they're actually saying if they were to do this over centuries and be successful, you could walk out of your habitat on Mars just like you do here on Earth and breathe and be okay in terms of not only oxygen, but temperature as well, which is very interesting.
Mm-hmm.
So so one of the things, Ben, in Truth in Lending sort of spirit, the authors say, they also address the obvious ethical concerns, such as the possibility of erasing traces, of indigenous, if I could say it, Martian life. So they recognize that, hey, there's some cautionary things here. And the researchers stress the need for thorough exploration before introducing Earth-based organisms to the planet. So they get that. But here's the thing that I was alluding to earlier about the early benefit to us now of this idea of centuries worth of time to transform Mars. So as a side benefit with application here on Earth, they argue that technologies developed for terraforming Mars could help combat climate change on Earth. So they're saying, hey, even though we recognize a lot of things about this plan, the technologies we have in mind to do what we want to do on Mars could be rolled over and help us here on Earth right now with climate change. And a final thing here, reality check. While the project may take centuries, the authors advocate for near-term, small-scale experiments to refine strategies for planetary engineering. So it's a really interesting paper. You should check it out.
For sure. And yeah, it's I've seen some things on terraforming Mars before, Ralph. This one seems to, have a lot of answers to a lot of the problems that, kind of come obviously on a time scale that, NASA has trouble planning 8 years ahead. Let's see what they can do 800 years ahead. But yeah, it's possible is what they're saying. And that is an important first key step. But everything I've seen, Ralph, is always like, yeah, terraforming Mars would be cool, but also taking care of what we have here and, any benefits that we can do to, kind of help with climate change here is probably the better route, take better care of Earth and then worry about Mars later. So,
yes.
Very cool. And yeah, hey, maybe applications here at home will, of course, be something that comes from this. So story number 2, and let's talk about, nuclear reactors. And this one's a bit different. This one is, I would say affordable. 165 million sounds pretty affordable. Well, that's what they've raised, and I'm sure it'll be a bit more than that. But still, Ralph, let's talk about nuclear reactors and how we're developing a world first here.
Yeah. And this comes from another outlet I hadn't referred to before called NukeNet. So nuclear net, nucnet.org. Interesting website, by the way. And the headline here, and we're going to get into this because there's a claim from this company about being world's first mass-produced nuclear reactor. We're going to have to qualify that, and you'll see in just a moment what I'm referring to. So the headline is Radiant, and Radiant is the name of the company, raises $165 million for development of what they say is the world's first mass-produced nuclear reactor. And we're going to explain why I'm hesitating on world's first in just a moment. But this is all about a trend, Ben, you and I have been looking at for a number of years. This race to develop small-scale nuclear reactors that could be deployed to data centers or deployed to areas of the world that are starving for energy and so on in a affordable, portable, practical way. This is part of that trend. So let's get into this.
So somewhere that you can take, fuel with you, and instead of taking, truckloads of gas and whatever it may be to generate fuel, you have one tractor trailer essentially, and you can tow this thing behind you and just bring essentially a city's worth of energy in one little truck. It would be amazing. So
yeah, exactly. So getting into the story, Radiant Industries, a California-based nuclear startup, has secured $165 million in Series C funding to advance the development of the Helios, I hope I'm saying that right, the world's first, they claim, world's first mass-produced portable nuclear micro reactor. Micro reactor is the buzz term. Now, a little reality check. This is where I'm injecting my personal comments. The article claims Radiant Industries has developed a world's first mass-produced portable nuclear microreactor.
I'll be right back. I'm sorry.
Sure. And several companies today are developing small-scale nuclear reactors focusing on compact, scalable designs for decentralized energy solutions. And now the thing I want to explain is they are not alone. Radiant is far and away not the only company looking at making small nuclear reactors portable and so forth. Other companies include NuScale Power, Holtec International, GE Hitachi Nuclear Energy. That's the big guy in this game. Another big guy in this game is Westinghouse Electric Company. There's another company called Terra Power. There's another one called X Energy, Ultra Safe Nuclear Corporation.
Rolls-Royce. I always thought the cars were expensive, and now it makes sense. They're nuclear powered.
Yeah.
I never knew.
Yeah, and like Rolls-Royce and so forth. So what we were doing, folks, is this is a roundup of some of the companies across the globe that are also racing to develop small portable nuclear reactors. So I don't mean to get down on Radiant, the company, for claiming world's first. It just is something you need to understand is a big, big trend in this area. And so regardless of the portability claim and being the first and so on, the key here is this trend toward development of small reactors. So back to the article, designed to replace diesel generators, the 1 megawatt micro reactor aims to provide resilient power for remote villages, emergency response efforts, and even military installations. Pretty interesting. Now, the funding will support the first test of the Kaleidos in 2026. That's the name of the small reactor from Radiant. And they're going to do this test in 2026 at the Idaho National Laboratory Dome facility. And the company plans to scale production to 50 micro reactors per year, with initial customer deployments expected in 2028. So once again, the big takeaway from this story, folks, is not quibbling about world's first, yes or no, up or down, but to be aware of this worldwide race to develop micro reactors. And I think, if I recall right, Bill Gates is very interested in this field as well.
Yeah, I mean, like, obviously there's a lot of talk about energy, of the future, sustainability, and, Ralph, getting one of these massive nuclear power plants that we have, the thing people think, the giant steam stack,
yes,
and, all that kind of thing, those can take upwards of, like, from being greenlit to actually producing energy can take decades, like 30 years or something like that, to get one online. They're super complicated. They're very safe, but they're very complicated to build. Ralph, if you could just build these on a bigger scale and not bigger scale, but more of them more often, this could solve so many of our energy woes. It's getting nuclear out faster, better, and hopefully safer. So there you go. It's even if they're not the first, Ralph, even if some of their claims are a bit more for the press release than they are for the facts,
right?
You're right. This is something people definitely should know about. So
exactly,
and we'll assume Kaleidos, something like that.
Something like that. Kaleidos or something like that.
There you go. So, story number 3, if you're following along in the show notes, which again you can find over on our website by the time that you hear this. Story number 4, let's go ahead and jump on down and let's talk about, blood stem cells for regenerative medicine. And turning your cells into stem cells is, of course, something big in this field. But Ralph, I'll let you go ahead and introduce story number 4.
Yes, this is a good one. And friends, what we usually do on Friday is, in our series of uplifting, positive, and interesting science and technology trend stories, I like to end with medical technology, because that's something near and dear to both me and Ben with our collective family histories in medical areas. And this comes from eurekaalert.org. Headline: a step closer to the confident, that's the key word, confident production of blood stem cells for regenerative medicine. We're going to explain all about this. This is a story that comes from the Hospital del Mar Research Institute in Barcelona, Spain. So this is very cool. Stem cells can produce, and a little tutorial here before we get into the news, stem cells can produce any other cell type. It is just a matter of telling them, so to speak, in the right way. And we're talking about genetic manipulation. From a biological perspective, this means activating the proper genetic program by pressing the right keys, meaning the right genes at the right moment. So that's a very simplistic layperson's sketch of what's going on here. And in the show notes, I add a little information about how stem cells can be transformed into a specific cell type. And you can go back to the show notes at computeramerica.com and geek out and learn all about that. It's absolutely fascinating, all about gene regulation and signaling pathways and on. It's stem cells. And it's just so interesting. You can come out to the show notes and learn more about that.
It's really crazy how far we've come with stem cells. And, I remember when I was younger, all of the controversy of, where you first found stem cells and where you got them from and how you gathered them. And Ralph, and now stem cell research is, blazing way because, hey, we can generate them from really anything that we want. So
yeah,
what a good development stem cells have been.
Yeah. Yeah. And in fact, it reminds me, I don't know, recently on a recent show, we talked about how there was a research team that was taking a patient's personal stem cells and manipulating them to grow teeth, replacement teeth. So this is a whole field that's just on fire right now, which is so wonderful. In this case, though, folks, we're talking about helping blood cancer patients, including leukemia and lymphoma. So these patients often require the replacement of their blood stem cells in the bone marrow, the tissue producing blood cells where their cancer grows. But I think, as we all know, unfortunately, finding a compatible donor to help a patient like this happens to be too challenging sometimes. It's almost impossible, right? So here's the premise that these research team folks in Barcelona were looking at. What if we could produce the cells needed to make blood in the lab, just like the folks who took the stem cells in the lab and grew teeth, right? So what if we could do that in the lab, right from basic stem cells, and use them to regenerate a new and healthy bone marrow? Remember, it's your bone marrow that makes your blood cells. To do this, you would need to know what genes to activate in a stem cell. Wow. In a tour de force, in a great achievement, a team at the Hospital del Mar Research Institute in Barcelona, Spain, screened thousands of genes in the mice genome, thank you, mice again, to see which were able to transform an embryonic stem cell into a blood precursor, or more technically, and I'm sure I'm going to butcher this name, it's very complicated, hematopoietic, that's hematopoietic stem cell. Okay.
Sounds right to me.
Yeah, there you go. The screening, their work identified a group of 7 genes apparently able to accomplish this task. And once again, in the show notes, I have a geek out side note on these hematopoietic stem cells if you want to learn about that. And it is very interesting. But going on in subsequent experiments, the team confirmed that the timely activation of 7 genes was sufficient to transform mouse embryonic stem cells into the hematopoietic stem cells, and that these newly produced cells were able to regenerate and sustain a functional blood system in the bone marrow, producing all kinds of blood cells, including the immune lineages in adult mice. So this is a very important breakthrough. Salute to the friends in Spain for pulling this off. What a great uplifting way to end today's main part of the show.
Of course. And yeah, just the research, and you could see how, Ralph, like what these stories have really driven home for me over the years is that cancer, like, I know, back in the 90s and, early 2000s, you're like, we're going to cure cancer. It is such a complex and difficult thing.
Yes. Yeah.
And, we're making great, we're seeing great advancements in the research and, the clinical settings. And, it is getting there. It is getting better. It's not cured yet, but stuff like this kind of, gives you hope that, hey, they're on the trail. They're going to cure this. It just takes a lot of it just takes thousands of mice and a lot of time. So there you go.
Well, and Ben, not to soapbox, and I don't want to be political, but to defund research across the world, or well, I should say in our country, to defund research in this area, it would be a tragedy. So let's hope that doesn't happen.
I really don't think that's political, especially here for Computer America, where, a lot of our guests on the program, over the lifetime of Computer America have been researchers at universities, have been researchers with private companies that, come on and they do collaborations with, government agencies. And, in the tech world specifically, it's, things are getting changed here, Ralph, and definitely not for the better when it comes to the research, the funding, and the, kind of the important research that people are doing in these fields. So, but hey, just like life, research, education, all that will be resilient. And hey, it's going to bounce back, and we should all value what the achievements that teams like this do every single day here on Computer America. So there you go, offer soapbox. And now, ladies and gentlemen, if you're following along and you are just now wrapping up reading Ralph's side notes in the show notes, well, at the end of the show, you may notice that we try to keep the show more condensed to a 4-story format, just to try to keep it closer to a half-hour listening program. But in the show notes, at the end there are the honorable mentions, and you can come out to Computer America. You can find these in the show notes at the end, and these we will give you the headlines, let you know what we're talking about. But if you want to find out more, you can go to the show notes, find the links, and find out more yourself, because these are stories that you should definitely know about. They are worth your time. It's just, hey, we have so limited time that come out to the show, and you can check them out yourself. So, Ralph, let's give them the headlines of story number 1.
Yes, you got it. This one comes from The Cool Down, which is an outlet via MSN. And the headline here was absolutely irresistible, and the story is equally great. Graduate student unveils plant-inspired technology that pulls harmful toxin from the air. And the subhead is totally different than what anybody else is doing. And the whole idea of pulling either carbon dioxide or other elements out of the air is another research trend around the world. So check that story out. That's a good one. And our next honorable mention is from Water Online. Headline, a fresh new way to produce fresh water. Sonicated carbon nanotube catalysts. Wow. So the whole idea of creating fresh water from salt water and so forth has been a field of great interest over the years too. And we've covered many, many times. This is a new one with this sonicated carbon nanotube catalyst. This is extremely geeky stuff, guys. Okay. I'll warn you there. Next one from the University of Washington newsroom. 3D printed device advances human tissue modeling. Organoids are a big trend. We all know about that. 3D printing of tissue is such an interesting field. This is a great example from University of Washington. Salute to those folks up north of where I live in Portland area. And our last one from SciTechDaily.com. New MIT tech could cut oil refining energy by 90%. Whoa. Wow. Yeah. Good old MIT. So that's a good story as well.
Yeah. And as always, some of these stories, they may not be the most high tech thing. I think oil is, something very, very old, but hey, reducing, refining, and hey, just making things more efficient. Sometimes that could be a breakthrough all in its own. So there you go. Ralph, the music in the background that you can definitely hear means that we are going to wrap up the show here. Ladies and gentlemen, if you want to find out more information, definitely check out computeramerica.com. It will have everything. Of course, check out the Ralph section. And on YouTube and social media and stuff like that, you can find more Computer America. Ladies and gentlemen, thank you so much for tuning into the program. And it's been a lot of fun. Ralph will be here every single Friday to talk about 4 of these amazing stories. If you want to hear more, you can, of course, always go out to the website and check that out. So, Ralph, until next time, everyone out there, thank you so much for tuning in. We'll catch you next time. Have a great day. Thank you so much. Bye, everyone.